This video will present to you the relationships between moments and the loading function W in deflection applications, and will also show you support deflection properties at boundaries and boundary conditions. Okay, now just to avoid confusion, in this course, capital V means the shear force and little v means deflections. I forgot to mention this in the previous video, but please remember that capital V is shear forces and little v is deflections. Okay, now recall from bending moments, shear forces and axial force diagrams. In the previous topic we discussed that when we differentiate the shear force, so dv dz, so capital V is the shear, we get minus w, we get the negative of the loading function, and when the differential, the first differential of a moment is the shear force. Okay, just remember this. Now, with respect to the z, the differential equations can be written as, from the previous equations, we found the governing equation of deflections was d squared v dz squared equals to minus mei. And if we this is the moment. If we differentiate once, we get the shear, which is d cubed v dz cubed, and we differentiate again, we get the loading function w. So minus m on ei differentiated once gives us minus v on ei. Differentiated once, since it's the negative of this differential, the negative cancels with this, we get the loading function w on ei. Okay, so we can use this bending moment twice. We can integrate the bending moment twice to get deflections. Okay, we can integrate the shear force 3 times. This equation can be integrated 3 times to get the deflection, or we can integrate